Everyone tells you to flat out memorize the unit circle, but nobody tells you where those numbers actually come from. So the unit circle is obviously just one big circle divided into 4 segments, like so, right? So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Obviously, we know that there are points on the unit circle, each with different side lengths in ordered pairs. We can represent that with these 3 points, right? So the x-axis of the unit circle is going to be represented by cosine of x, right? So let's just write cosine of x, or theta in this case, and the y-axis is represented by sine, right? So we can write sine of x for the x-axis. Now, from here, we have 3 angles already right now. So one angle going from the center to this point right here, we can draw a vertical line, giving us that triangle, right? What is this angle? Well, I'm sure many of you already know what this is, and this is actually pi over 6. You might be wondering why this is pi over 6. It's because a full circle is represented by 2 pi radians, and when switching to degrees, this is actually 360 degrees, right? So if we divide both sides by 12, we have 30 degrees, right? So pi over 6 is the same as saying 30 degrees, meaning that this angle right here becomes 30 degrees, right? Now if we have a right angle created by this perpendicular line, we have 90 degrees, 30 degrees, and this has to be 60 degrees, right? That gave us a 30, 60, 90 triangle. Right? 30 degrees, 90 degrees, right angle, and 60 degrees. Now, the side lengths with this are usually 2 for the hypotenuse, 1 for the shortest side, and then square root 3 for the other leg, right? Since our radius, we already know for the unit circle, is 1, we need to divide everything by 2 to get our radius to become 1, right? So doing that is going to give us this leg length of square root 3 divided by 2, obviously, so that becomes the cosine for pi over 6, and then dividing the other shortest leg by 2 is going to give us 1/2. So now we have the coordinates for pi over 6, right? Sine pi over 6 is 1/2 because that's the height or the y-axis, and then cosine of pi over 6 is square root 3 over 2, right? Now that we have that down, let's go to the other leg right here. We draw that flat out, and we draw this fake vertical line going down here. Now we have a right angle right there, and the 30 degrees actually switches to on top, and the 60 degrees comes down below. Now what this does is that changes the orientation of our triangle. And what happens is basically the cosine and the sine values switch, meaning that the cosine becomes 1/2, and the sine value becomes square root 3 over 2, right? Now, you'll notice we also have this line in the middle. So if I were to draw a line right here, that would be represented by something like that. Now this is actually a misconception. People think it follows the same rules. It does not. It's a 45, 45, 90 triangle. Now what are the side lengths with this? It's usually 1 for both sides and then square root 2 for the hypotenuse, right? As we discovered before, the radius is 1, meaning we need the square root 2 to become 1 to fit the unit circle. Dividing each side by square root 2 to get 1, we're going to have a side length of 1 over square root 2 for both sides, which rationalized is square root 2 over 2, right? Now, that means that this triangle has a cosine of square root 2 over 2 and a sine of square root 2 over 2. Now, I'm going to teach you a trick for solving for the tangent. Tangent usually equals, I'll draw it right here, usually equals sine of x over cosine of x, right? But I'm going to teach you this trick. When we have a triangle like this one with pi over 6, where it is more flat than tall, the tangent is going to be 1 over square root of 3, and when we have one that's taller than flatter, the tangent is going to be square root of 3. Obviously, this is going to be adjusted to each of these quadrants, but I want you to try and figure out the tangent for this pi over 4, right? And then see if you can figure out the tangent values or the sine and cosine values for each of the other angles in the unit circle. Thank you for watching, and let me know if you want a part 2.